giving you 1 or 2 minutes. Put the answer on paper. Then when I select you, you should be ready to read for us that answer. So the question we are answering is, describe the shape of the graph. That's the question that we are answering. And I've told you the words we are going to use: decrease or increase, rapid or gradual. And when you're quoting figures, we quote the figures on the horizontal axis accurately. We never mention any figure on the vertical axis. Okay, so who is done? Lona, it was your chance. Lona, are you through?
Yes.
Okay, read for us the answer.
From 44 degrees to 44, from 10 degrees to 44 degrees, the rate of reaction increased rapidly. Then from 44 degrees to 50 degrees, the rate of reaction decreased gradually.
Now, what is the meaning of the word gradual? If we don't use the word gradual, which other word can we use? Yes, Lona? Flavia, Flavia give us the answer.
I think we can use slight.
Slight. Isaac?
Yeah, gradual is the same as though.
Okay, thank you. Now, when you're describing, avoid using the word slight. Avoid using it. Avoid using words like exponential. Avoid using words like drastic. If something is decreasing, if something is changing slowly, you either use the word slow or gradual. So avoid using the word slight. Hope that one is clear. If something is changing rapidly, only use the word rapid. Don't use any other word. Hope that one is clear. Now, when you look at this graph, honestly, from 10 to 20, is this change the same as from 20 to 40?
Yeah.
Yes,
No.
Is it the same?
Yeah.
No.
So which changes are there? From 10 to 20, then from 20 to 40 or 44. Which changes are there? Yes, Lynette.
From 10 to 20 degrees Celsius, the increase is gradual. And from 20 degrees Celsius to 40, the increase is rapid.
Then from 40 to 44?
From 40 to 44, it's constant.
Then from 44 to 50?
It decreases rapidly.
Rapidly. That is wonderful. Thank you so much, Lynette. So now, when I look at my graph has about 4 points. My graph has about 4 points. These 4 points are, you can see that from 10 to 20, that is a change. From 20 to 40, that is a change. Then you can see that from 40 to 44, that thing is remaining almost constant. Then from 44 to 50, you can see there is a rapid change. So it means those are going to be your points when you're describing such a graph. Even you may find that that question, if it was set like that, it would be having about 4 marks, each mark for its own point. So therefore, even when you're writing down your answers, feel free to write them down in bullet form, in bullets. For instance, you'll say, the first bullet you'll say, from 10 to 20 degrees Celsius, the rate of reaction increases gradually, full stop. That is point number 1. Then point number 2, from 20 degrees Celsius to 40 degrees Celsius, the rate of reaction increases rapidly, full stop. That is another point. Then you go to your bullet number 3, from 40 to 44 degrees Celsius, the rate of reaction remains constant, full stop. You go to point number 4, from 44 to 50 degrees Celsius, the rate of reaction decreases rapidly, full stop. That is how we describe graphs. Danny has sent his question inbox. Now, some of you, if I don't get it, if you don't get a chance to, if I don't select you, you can forward your question in the chat. Dan is saying, Master, have not given us the other word to mean gradually. Oh, now the other word to mean gradually is slowly. When you're using the word gradually, you either use gradually or you use slowly. So that is the other word to mean gradually. A change is, if you say slow, don't say slow. It's the same. Okay. Yes, Isaac.
Oh no, teacher, I just forgotten my hand up.
Lynette, anything?
No, I just forgot my hand up.
Karen, anything?
Teacher, I would like to know how you know whether it's gradual or rapid, because in my opinion, I would have said that from 20 to 30, it is rapid, and then it's gradual according to the distance I'm seeing. Like, for example, I consider the number of boxes.
Okay, I'll answer that. SC?
Yes, sir. So I have a question from 40 to 44. Can you say from 40 to 44, the rate of reaction increased? No, the rate of reaction remained almost constant, because it doesn't look like it's constant.
Yes, if it doesn't look like
it's
you
constant.
Can use almost. If you see that the graph, you can see it is constant, but not very constant. Then you can use the word almost constant. It is all right.
So can you also add to a peak?
Now, if we didn't have those 2 points, if we only had 1 point at the top there, then we'd have described it as a peak. If we didn't have that 1 point there, would have described it as a peak. Yes, William?
I just want to ask for a pardon with the answer.
Oh, the answer. Okay, I'll also get it. I'll wrap it up. Now, let me go to the question where I've forgotten the name. How do you know that it is rapid, and how do you know that it is gradual? Now, we look at, it is like climbing a mountain and going down a slope of a mountain. You can see that this thing is very steep and this thing is not very steep. So if you look at someone is babysitting. Okay. Now, you just use your eyes, you look at the graph, you see where the graph is having a steep change. Now, for instance, when you look at this graph here, so I can use, maybe I can use a line. So I can see this one here, then I can see this change here, then I can also see this change here. So I can clearly see that from here to here, this one here, I cannot compare it with this one here. So I look at the steepness of the graph is what I look at, the steepness of the graph. If the graph is very stiff, so that is very, has a big, maybe like kind of a steep slope or a steep increase, then that change is rapid. If I see that the gradient is not so steep, then that is a gradual change. So it means that this one is steep. So this is a rapid change. This also is a rapid change. Then this one is a gradual change. I can have maybe another graph like this. I can have something doing like this. I can have this, 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 like that. So I ask myself, which changes are here? I have to identify which one is rapid and which one is gradual. So I can see that, let me use another color. I can see that from here up to here, that change is rapid. Then from here up to around here, that change is gradual. Then now, this one here, is it gradual or rapid? I can draw my imaginary lines. I can do this, then I do this. Obviously, I will see that these are different changes. So it means I'm going to describe, this one as rapid, then I describe this one as gradual. So you just use your eyes to see where the change is rapid or where the change is so steep and where the change is less steep. That's how we know. Otherwise, we don't count the number of points. That now, here I have very many points, here and here. Here I have a few points, then this is gradual. Then here I have many points, this is rapid. No, you look at the extent of the change. Then Maria is saying, sir, what if they ask that describe the trend of the graph? Is it the same as that question? Yes. As long as they mention the word describe, then there they can use other words. They can say describe how the rate of, how temperature affects the rate of reaction, describe the trend of the graph, describe the shape of the graph. As long as they're using the word describe, it is what we are learning to do right now. Then Ben Casso is saying, sir, I think from 40 to 44, the temperature is gradual or almost constant. Now you have said almost constant. You can use your eyes. You see, if it is confusing, then you can say almost. Okay. And then Ariagaruka is saying, teacher, please pardon on the answer. I'll repeat the answer, don't worry. So I hope now we have known when to know that the thing is gradual or rapid. Is that clear? So how did I describe my graph? Those ones who are asking for a pardon of the answer. This is how I describe my graph. The first thing is to identify the change points that you have. The first change point is here. The first change point is here. So you can see that from here to here, it is gradual. Then from here to here, it is rapid. Then you can also see that now from here to here, it is almost constant. Then from here to here, it is rapid. Therefore, what is the answer? I say from 10 degrees Celsius to 20 degrees Celsius, the rate of reaction increases gradually, full stop. That is the first point. Then you go to the next line, you write another point. That from 20 degrees Celsius to 40 degrees Celsius, the rate of reaction increases rapidly, full stop. That is the second point. Then you go to the next line and you write the third point. That from 40 degrees Celsius to 44 degrees Celsius, from 40 to 44 degrees Celsius. What are we seeing? We are seeing that the rate of reaction almost remains constant, almost, because if I'm connecting these points, it's almost constant, though there is a forced curving there. So I will say from 40 to 44 degrees Celsius, the rate of reaction remains almost constant. Then the last point, from 44 degrees Celsius to 50 degrees Celsius, the rate of reaction decreases rapidly. So that is how I would describe that graph. So it is important to note that what is changing in this case is the rate of reaction. Don't just say that from 10 degrees Celsius to 20 degrees Celsius, there is a gradual increase, full stop. I'll ask you, a gradual increase of what? So there is a gradual increase in the rate of reaction. Hope that one is clear. Okay, then we can now proceed to the next thing. Okay, then part B is saying, at what temperature is the rate of reaction fastest? At what temperature is the rate of reaction fastest? Denise is asking that, does the tense used matter? As you say increases, or you can say increased. Now, the tense does not matter. Remember, you are reporting. You can report in continuous tenses. You can even report in past tenses. The tensing does not matter. You can either say increases or you can say increased. Okay. Who can give us at what temperature is the rate of reaction fastest? Yes, let's see. Lona, give us the answer. 5.
Please repeat the question.
45 to 50.
Faith is saying, the question is, we are answering part B. Part B is saying, at what temperature is the rate of reaction fastest? Faith, I beg your pardon?
45.
45, okay. Lynette?
40 degrees Celsius.
40. William?
44 degrees Celsius.
Sorry, 40.
40, 44. Okay, let us see. Now, in this case, let me first see what I have in the chat. 35, 30, 35. Okay, now, in this case, we can clearly see that this rate is highest in this range here, this one here. So it means any temperature in this range is correct. Only temperature from that range. If temperature is lying out of that range, then that is not correct. And which temperature is that? We are saying it is in the range of 40 to 44. So it means the answer must be 40 up to 44. But you quote one temperature. Because the question is asking you at what temperature, not at what temperature range. So you just speak out one. So I expected it to hear 40, 41, 42, 43, 44. Any of those temperatures. Okay. I hope that one is clear. Then now, we can now go to the most challenging part.
Rain.
Part C. Explain the effect of temperature on the rate of the reaction. That part C. Explain the effect of temperature on the rate of the reaction. Now, take note. When they give you graphs, of course, the first thing they can always ask you is describe. Describing we have learned. Then after describing, there is no way you're going to escape a question about explaining what you have described. Now, under the explanation is where you use now the biology. You realize from whatever I have been mentioning, there is no biology at all. Whatever I've been telling you, we just see what is on the graph and we report what is on the graph, as simple as that. Nothing like the biology. That means if you are to answer explanation question, explain. That's why you need to know the topic from which the question is coming from. You need to know the topic from which the question is coming from. Because that is the content that you're going to use to explain. And I believe all of us must have looked at this topic at school. Was you must have covered this topic either this term or sometime before you went for lockdown. Nutrition, and specifically enzymes. So, in other words, they are saying explain the effect of temperature. What is the effect of temperature on this graph? From the graph, we can see that an increase in the temperature results into an increase in the rate of reaction up to a maximum point or up to a peak. Then you can also see further, we can see that higher temperatures beyond the optimum result into a rapid reduction in the rate of reaction. Now the question would be to explain why that is the case. Mr. Kaziva, I think there's people in the English session, they want some help. Can consider. Okay. So now we are going to see how do we explain. How do we? Now Ben Casso is saying 40 to 45. Rate of reaction is gradually decreasing. Ben Casso is saying gradual means slow. Is this decrease slow or rapid? This decrease here, is this slope steep or not steep? Then
it is steep.
And now, if it is steep, then why are you saying that it decreases gradually? If it is steep, then the change is rapid. Now, how do we explain such a graph? Now, take note that when they ask to explain in a graph, the first thing to do is to describe. Then after describing, you go on and explain. So in other words here, we shall ask ourselves, because what we are seeing here is that from 10 to 20, the rate of reaction is increasing gradually. Now the question will be, explain why. So it means you're going to reason why from 10 to 20, the rate of reaction is increasing gradually. Then the second point is, we can say that from 20 to 40, the rate of reaction is increasing rapidly. Then the question is, why? Why is it increasing rapidly? Then you have now to give us the biology behind that. So that is how explanation questions are answered. You get out the biology, and this biology you must have learned, or you must be able to recall it from what you learned from that specific topic. Now, if I may ask you a question, why does the temperature increase gradually So why does the rate of reaction increase gradually from 10 to 20 degrees Celsius? Who can give us an answer? Yes, William?
I think the rate has just started and the enzymes are not yet much activated.
The enzymes are not yet much activated. Fair, correct? Thank you. Karen?
I think because at that point, the temperature is still low.
The temperature is still low. Ben Casso? Ben?
I think there is a gradual increase in the rate of reaction because the enzymes are always inactive at temperatures.
Because enzymes are still inactive at low temperatures. Okay. Okay, so I think we can pass that. Well, that is correct. Now, first of all, this question is coming from the factors that affect the rate of enzyme activity. Basically, coming from the section where we learn the effect of temperature on enzyme control the reactions. That is what we use. Let me first mute these ones who are making for us noise. Okay. Now, how do I explain? So my first point would be, of course, remember I told you that before you explain, you describe. Then after describing, you put there the explanation. Okay. Then, so I'm going to say that from 10 to 20 degrees Celsius, the rate of reaction increases gradually because then I give my explanation. Now, I don't have to first describe the whole graph and finish it. Then after describing the whole graph and finishing it, then I come to the explanation. No, that is not the proper way of doing things. You describe section and explain it. Then you come and pick another section and you also explain it. So here I will say that from 10 degrees Celsius to 20 degrees Celsius, the rate of reaction increases gradually because at low temperatures, most of the enzymes are still inactive. Because at low temperatures, most of the enzymes are still inactive. Full stop. That is my first point. Are we clear? I hope I'm not moving so fast. Then from 20, now after writing that point, and of course, when you're writing your answers, don't write as if you're writing an essay or you find a paragraph of about 7 lines. Every point you make, that is a full stop. Then you come to the next line, you start another point. Whether you're using paragraphs or you're using bullets, it's all right. Then, now the second point would be from 20 to 40 degrees Celsius, or maybe I can now say, yes, from 20 to 40 degrees Celsius, the rate of reaction increases rapidly because I now give my explanation. The first thing to do is to first describe what you're going to explain. So I've said that from 20 degrees Celsius to 40 degrees Celsius, the rate of reaction increases rapidly because an increase in the temperature activates more enzymes. Hence, most of the enzymes are activated because an increase in temperature activates more enzymes. Therefore, most of the enzymes are activated. So that would be now the explanation for that rapid increase. Are we there? Are we moving together?
Yes.
Okay.
Yes.
Then my third point would be from 40 to 44 degrees Celsius, the rate of reaction is at its maximum. From 40 to 44 degrees Celsius, the rate of reaction is at its maximum because that is the optimum temperature range. Because that is the maximum temperature range. So not maximum, optimum. Because that is the optimum temperature range where all enzymes are activated. Where all enzymes are activated. Because that is the maximum, sorry, because that is the optimum temperature range where all the enzymes are activated. That is the explanation for why the rate of reaction is at its maximum. And we now go to the last point. Are we there? Are we there?
Yes.
Okay. William, you forgot your hand up or you have a question?
I had forgotten.
Okay. Then the last one. From 44 degrees Celsius to 50 degrees Celsius, the rate of reaction decreases rapidly because from 44 to 50 degrees Celsius, the rate of reaction decreases rapidly because, so I have finished describing. Now I'm going now to explain why. This one is very obvious. Who can now add on that statement? Yes, Karen.
Because enzyme activity is denatured at a high temperature.
Is it the activity which is denatured?
Enzymes are denatured at a high temperature.
Thank you. So that is true. Very high temperatures denature enzymes. So we shall say, because remember we said that from 44 to 50 degrees Celsius, the rate of reaction decreases rapidly because very high temperatures denature enzymes. Because very high temperatures denature enzymes. Therefore, enzymes are being denatured rapidly. Therefore, enzymes are being denatured rapidly. So that is how we explain such a graph. So it is clear. Now, what have we learned from this one here? We can use this graph. We can use this graph. We can use this graph to what we have learned from this graph is that we must have learned how to describe graphs, that we use figures on the horizontal axis only, and we must quote them accurately. Then secondly, when we are explaining graphs, you first describe, then after describing, you give a reason. But that reason is coming from the biology behind that experiment. Shada is saying, please repeat explanation from 10 to 20. From 10 to 20, those ones who have been reading, what did I say? From 10 to 20. Who can read for us what we said from 10 to 20?
From 20 to 30.
10 to 20.
From 10 to 20 degrees Celsius, the rate of reaction increases gradually because of low temperatures. Most of the enzymes are still inactive.
Wonderful. Because at low temperatures, most of the enzymes are still inactive. Shadai, I hope you have got it. Then, yes, William?
What if from 44 to 50, I say the rate of reaction from 44 to 50, the rate of reaction decreases rapidly because beyond optimum point enzymes are denatured. Is it
right? Yes, it is also correct. If you say beyond the optimum temperature, enzymes are denatured, it is also correct. But what is more accurate is you telling us that it is because of the very high temperatures. Obviously, it means that beyond optimum temperature, then the temperatures become so high. So it is still correct. Okay, Akram is saying, how about decreased? What do you mean, Magoba? Decreased, what about the decrease? Magoba, your question is not clear. Maybe you can unmute and you tell us. Akram. Akram, we can't hear you. Okay. So that is question number 1. And I hope now from question number 1, we have learned a lot about graphs. And let me hope that you won't find any challenges so far from now onwards of describing graphs. Then Kauta Edgar is saying, how do we estimate that it is 44 exactly from 40 to 50? Oh, estimate that it is 44 exactly. Now, there we don't have any formula, but you have to be creative. For example, how did I know that this point here, how did I know that this point here is 44 and not 45? So there you have to be very creative. You have to be innovative. So how did I estimate it? Of course, I saw that from 40 to 50, in between that is 10. So it means if I look at this line here in the middle, so this line must be for 45. But when I look at this point here, it is slightly behind 45. Hence, I estimated it to be at 44. That's how I estimated it. You estimate. You have to be very creative. And you estimate it accurately. Okay. So, can we now go to question number 2? Someone is saying that what are the key points in explaining? Okay. Now, the key points in explaining. Actually, first of all, you should ask yourselves, what is the meaning of the word to explain? Now, to explain means to give a reason why certain change. Give a reason for something. Now, the key points are, you first describe the change, Then after describing that change, then you give the reason why. That is the explanation. Say that there is a gradual increase from point A to point B. Then give us the reason why that change. So I'm hoping that one is clear. So maybe that one, I can take that one as the key point for explaining graphs. You first describe, then after describing, you give the explanation. Yes, Teacher Eva, you're welcome.
Thank you, Teacher Arthur. I just wanted to, maybe the one who said, what about increased? Could he have been talking about the tense that is used in this case, increases or increased? Probably that was his idea.
You can comment on it, Teacher Eva. You can help him.
No, the tense wouldn't matter in this case as long as you're describing, talking about that this increased like this is okay because the experiments happened in the past, but also to say that when this happens like this, like from 0 to 10, the rate of 0 to 10 degrees Celsius, the rate of reaction increases is also okay. So that should not put him really on tension.
Okay, thank you. So the tense does not matter. For us, what matters is the biology. Is our biology there? Okay, so we can now go to question number 2. So I think question number 2, we shall not spend there much time because now we have known how to answer graphical questions. Now, let us look at this question 2. Remember, I told you that the first thing to ask yourself, from which topic is this graph coming from? Because that is the explanation that you're going to use when you have been asked to explain. So students, the question is saying the graph below shows changes in the concentration of carbon dioxide above the leaves and the mass of sugar in photosynthesizing leaves through 24 hours of the day. From which topic is this coming from? Yes, Lona. Lona, are you there?
Transport.
Lona is saying transport. Yes, Karen?
Photosynthesis.
Photosynthesis. Okay. The first thing is always get the topic right. So, yes, there is some aspect, there can be some aspect of transport, maybe, because maybe treatment of these substances, but this must be coming from nutrition, that is photosynthesis. So it means as you prepare yourself to answer this question, in your brain, you must now be processing all the things you learned about photosynthesis, all the factors that affect photosynthesis, the importance of photosynthesis, everything that goes on with photosynthesis. Now, if I may, so given that now we know how to describe, let me see the first question. For the period shown, describe the changes in the Roman number 1 concentration of carbon dioxide. I want a student to answer for us that question, Roman number 1. They are saying, describe the changes in the concentration of carbon dioxide. So this is the graph. Who can give us the answer for that part A? The question is, describe the changes in the concentration of carbon dioxide. Describe the changes in the concentration of carbon dioxide. Of course, first write the answer down, then you're going to read for us the answer, what you have written. I think I should give you about a minute. Write the answer down, then you read for us the answer. The question is, describe the changes in the concentration of carbon dioxide? That is the question that we are answering. Describe the changes in the concentration of carbon dioxide. Anyone done with writing the answer? Write down the answer, then read for us what you have written. Who's done? Who's done? Come on, please. We've just looked at describing graphs. Okay, yes, Faith?
Pardon the question.
The question is there. Part A, Roman number 1. Yes, Laban?
There was. Yes.
From 4 to 12:30, the concentration of carbon dioxide decreases rapidly.
Yes, go on.
Yes. Then from 12:30 to 4, the concentration of carbon dioxide increases gradually.
Okay, thank you. Can now have another one. Jasmine Drake. Read for us what you have written. Jasmine. Okay, someone is using Technopop 5. I can't get your name. You read for us what you have written. The one using Technopop 5. Unmute yourself and read for us what you have written.
Are you getting me now?
Yes. What is your name?
Yes. My name is Charles.
Pardon?
My name is Charles.
Charles, okay. What have you written?
I have here that from 4 to 12:30, the concentration of carbon dioxide decreases rapidly. Then from 12:30 to 16, the concentration increases gradually. Then from 16 to 4, the concentration increases rapidly.
Okay, thank you. Then you can have another one. William. What have you written?
From 4 hours to 12 hours, the concentration of carbon dioxide decreases rapidly. And from 12 hours to 16 hours, the concentration of carbon dioxide almost remains constant. Then from 16 hours to 4 hours, the concentration of carbon dioxide increases gradually. Then from 4 hours, from 4 hours to 00 hours, the concentration, from 00 hours to 4 hours, the concentration of carbon dioxide increases rapidly.
Okay, thank you, William. Lynette? Yes, Lynette?
4 hours. Yes, from 4 hours to 8 hours, the concentration of carbon dioxide decreases rapidly. And from 8 hours to 12 hours, the concentration of carbon dioxide decreases gradually. From 8 hours to 14 hours, the concentration of carbon dioxide decreases gradually. Then from 14 hours to 22 hours, the concentration of carbon dioxide increases gradually. And from 22 hours to 4 hours, the concentration of carbon dioxide increases rapidly.
Okay, thank you, Lynette. Now, first of all, I'm happy that all of you are describing correctly. Now, maybe the only challenge will now be identifying where that change ends and where that change starts from. Now, there are some slight changes which you can always ignore when describing your graphs. For instance, when you look at this graph here, here, someone said it remains constant there. Yet what we are seeing something like this. So in this case, what we do, we establish where there is a slight change. So if it is like this, then I have to look for the middle of it. So it means I will say this side it is decreasing, then this side it is increasing, as simple as that. Because you will not have a graph with a perfect V like this. It will always be kind of a curve. Why? Because in biology, when we are plotting, we don't use rulers. We use our free hands. So we expect a free hand to give you something like a curve, not a perfect V shape. So we just have to estimate the mid piece like that. So when I'm looking at this graph, I would do, so first of all, let me first clear this. So when I look at this graph here, obviously I can see that there is a change, a decreasing change from here up to here, like this, like that. So this change, I can describe it as a rapid decrease. This change here, you can describe it as a rapid decrease. Then another change that I'm seeing this change here. Now, when you look at this graph that is increasing, obviously there is somewhere where it is changing here. You notice there is something unique here. Even if you were to draw a straight line, you'll find that this one will go like this. Then this one will go like this. So find that now this one is serving as an intercept. This one here is serving like an intercept, like that. So it means one will be gradual, another one will be rapid. So I will take this one to be rapid. Then I will take this one to be gradual, like that. I hope I'm clear here. So therefore, it means that from 0400 hours, from 400 hours,
I'm sorry, students.
Is it my network or the teacher is off?
The teacher is off, although I wasn't following where he had stopped. Do we have any questions to answer as we wait for him? Oh, he's back, I think. He's connecting, so let us be patient.
Okay, sorry for that, I'm back.
We are not seeing anything.
The teacher's screen is off.
Yes, it seems the teacher is having network problems, so let's be patient. He seems to have gone.
Okay, madam.
Let us mute. I see microphones opening. Unless you have a question to ask. In which case you'd first raise your hand. Yes, Vivian?
I would just like to know the question because I'm not getting because I never had the question.
No, there is not been a question since the teacher went off.
Oh,
but
the one the teacher was working out.
It was working out the one of carbon dioxide, I think it's number 2. Number 2, the graph of number 2, that's what we were describing. Should I ask if everyone is comfortable with describing such a graph? Vivian, have you traced the number?
Let me try to trace it.
Yes. Yes, Maria Goretti.
Madam, I was asking that the way you answer the graph one, is it the very way you answer about graph?
The way you answer?
The question one, the way we answer question one.
People, can we mute? I'm not getting Maria very well. We are getting feedback. Please mute. Maria, you're going to repeat your question. Techno Pop Cool Sharks, mute. Okay, Maria, you can now mention your question.
Madam, the way we answered question one, is it the very way we can answer a bar graph?
A bar graph, eh? Now a bar graph is plotted on particular types of data. I think we'd have to look at the bar graph and see. The key things to notice when we are describing a graph, we must mention the change on the horizontal axis, and we must quote units there, like let's say from this time to this time. Then we go onto the vertical axis and see what change took place. Okay, so if it was a bar graph, unfortunately, I don't have one here. If it was a bar graph and the bar is really tall, you could say from maybe January to March. Now that is what would be on the horizontal axis. They are months, eh? January to March. Then if on the vertical axis it is amount of food eaten, you'd mention the amount of food eaten was a lot, for example. So you might find yourself with bar graphs not using terms like increased rapidly, and so on, because the bars are not exactly showing that, they're just showing direct amounts of substances. So we need to interact with the bar graph to see. But one thing that does not change, you must quote what is happening on the horizontal axis correctly. Then on the vertical, we just mention in quantity, we don't mention the figures. Have I helped you, Maria?
Yes, madam.
Okay. If you have a question, you raise your hand. Okay, since we do not have any people asking, it's almost time for the end of the lesson. Yes, Judith.
For some graphs, they start actually when it's initially almost constant. Then how do we compare those questions?
It's still the same thing. For you, the skills that teacher Arthur has given you are enough. Yours, you're going to see the different parts of the graph. If it is starting when it's constant, I think that is what is happening with the graph he was just describing for the concentration of carbon dioxide, the mass of the sugar. If you look at that graph, it is okay. See that part and gauge on the horizontal axis, where does that part fit? From what time to what time? Mention it that from 0 hours to 6 hours. Then you go and read off what is on the vertical axis. Let's say the mass of sugar remained constant. So don't fear, the graphs can come in any shape. They could start by increasing rapidly, then they decrease. They could start by being constant. They could start by decreasing. You can do that as long as you maintain the skills that you have picked up. Is that okay? So from the lesson that I have followed, I believe all of you should be very capable of handling questions on graphs. Technopop.
Madam, I wanted to find out now, if we end this lesson, we have not completed these questions, is there a possibility of us having another day for completing this?
I am not sure, but first of all, I want to encourage you to complete those questions. You as an individual, you've picked the skill, okay? Then
yes.
In check books, because he said after this, the explaining, you need to know your biology. So refer to your notes and try to explain. Then when we get an opportunity to come back, we shall complete. But if we do not, you can go to school and continue with it with your teacher. Letitia, yours is the last question, and then we wind up. Letitia, I can't hear what you're saying. No, please draw near to your microphone.